If I want to refer to my notes and such, should I situate myself right here?
Yep, and we should be going live now. Okay. Oh, you don't need to. Okay, you got the lights on you.
Great. So, good morning, everybody, and welcome to today's professional development seminar on flattening and interchange, managing client priorities. And our presenters are Jared Travis and Will Yu. And Jared is right here before me. He's got a checkered background. He actually he started out as a water resources engineer. He was on the right side of the world, like me, but then he went into transportation engineering. Came up to Alaska in the year of 2003 for wildland and fire issues and training. He's done he got an undergrad at University of Colorado Boulder and a master's at Northern Arizona University. So welcome. And so Will Yu is actually in Portland, but he's online. Thank you, Will. He's a senior transportation engineer with ATR, and his specialty is design of innovative interchanges. Will has done work in all around the world, including Australia. So thank you, gentlemen, for coming and presenting, and take it away.
Thank you so much. So we have a pretty crowded room here today. We've got two folks here live. I'm not sure how many we got out there in the webosphere, but welcome all. My name is Jared Travis, transportation engineer with HDR. Presenting today with Will Hume out of our Portland office. He's a senior transportation engineer, also with HDR. We're taking a step back. We'll be presenting not just this project, but a little bit about the profession of transportation engineering. Here are a couple of the learning objectives we will be touching on today. We'll be focusing on a project out of Fairbanks, Alaska. It's called GARS. That's an acronym that I'll introduce to you with more specificity in the upcoming slides. But via the dialogue of this project, we'll be touching on these learning objectives: designing smart by leveraging site-specific opportunities, addressing constructability of complicated projects, and very importantly, engagement of the public. A short lag in the transition of these slides. So here's the general outline of the presentation. You may notice there's a bit of a theme. Once upon a time, we've given this presentation before we had soundtracks to go with it. I'm hoping will time in with some beatboxing later on, but it's the best we can do today. The mission. Chapter 1. So here's the intersection of our focus today. This is in Fairbanks, Alaska. This is the nexus of Airport Way, Gaffney Road, Richardson Highway, and Steve's Expressway. Some of you may be familiar with this intersection. In fact, slipped backwards there. But there's a lot going on at this intersection. It's a priority 1 intersection. That's engineering and transport lingo for it's really important and heavily used. We have the Richardson Highway progressing from the south. Boy, I'm not sure why it slips backwards. Oh, this is you, Will. Here I am touching buttons and I should be cueing you. Next slide. Unfortunately, I can't see my notes, but we got some 500 miles of Richardson Highway coming up from the south, and another 400 on the next slide. You'll see about Dalton Highway, which extends to the north What does that mean for this project? It means a couple of different things. It sees a lot of traffic and it sees a lot of very, very heavy vehicles. This is something you need to consider in your engineering plan. But the roadway structure needs to support not only a lot, but some very significant vehicles and their turning radiuses. Next slide, please. Level of service, this is again some engineering and transport lingo for how well is this intersection performing today. Some of you may be more familiar with what an F means than others, but it's not good. It's also a very dangerous intersection, and this project is funded by HSIP funding. That means it's paid for by government dollars. Their focus is on safety of the community. So safety, as always, but particularly with an HSIP funded project, is of the utmost priority. Next slide, please. Unfortunately, I can't see the notes. So we were handed, HDR was handed a preferred interchange concept. The way a project works is there's a lot of months and years go into a design before you really start getting down to the nitty gritty. It's kind of a conceptual feasibility phase of the project. And this is the design that was brought to our table. And it's not the design we ended up implementing. There are pros and cons to this diverging diamond design. You may have seen diverging diamonds in Anchorage. But there's pros and cons to this design. The pros are typical to DDIs. It could handle the capacity. That's how much traffic can we move through the intersection. It can handle some of the heavy vehicle traffic, not only for vehicles heading north to the north slope, but also from the Fort Wainwright to the east of the intersection, and it handled capacity. But it did close the 10th Avenue north of this image. 10th Avenue is a left turn westbound, which handles an awful lot of traffic. And the reason it closed is because those ramps in the northeast and northwest quadrants extend quite a bit north. So that was a bummer that we weren't ready to pallet. And then it also involved right-of-way acquisition. In general, or always, that's something we try to avoid in construction and transportation projects. You don't want to take people's private property. Next slide, please. So the question arises, is this mission impossible? And what tools do we have in our toolbox that we could implement to solve some of these issues? I'll hand it over to Will.
So at the moment, the current plan was to build a grade separation, full interchange at GARS, a DDI that's going to improve safety by removing conflicts and improve congestion by adding capacity via the free flow movements and the grade separation. However, once we started designing that, we got to an estimate, an engineer's estimate that was close to $47 million. The client, the DOT, Department of Transportation, said, hold on, are we sure this is the right solution for this intersection? And essentially what was a catalyst for us to take a step back and almost reevaluate the entire solution was the fact that Jared mentioned HSIP funding. That is a program for the state of Alaska where they have $50 million annually to spend towards transportation improvements that are going to have a significant reduction in crashes. This one project was going to eat the entire funding for the entire state, essentially, and therefore hundreds of other projects that would be funded that is also going to improve that would also improve safety would therefore not be constructed. And that's where we were asked, hey, is it possible to, one, reduce crashes, two, improve congestion, three, provide the same type of level of service that a full-blown interchange was going to provide, while also, I don't know, maybe only costing about a third the price of a full-blown interchange. And that is really the question of, is that possible? So knowing that, we had to really look at a proven solution that is going to reduce crashes and a proven solution that's going to increase capacity. Really, we need to almost immediately go to something a little bit more atypical than your typical widening. So when it comes to an intersection, there's really only two ways to add capacity to a signalized intersection. One way is to increase the flow of traffic through the intersection within the same amount of time. And that means you're going to add lanes and you're going to widen your roadways to increase the number of vehicles that can go through it within every single cycle length. The other option to increase flow in a set time is to eliminate the conflicts and essentially grade separate. We knew that wasn't going to be viable because of the cost. The other way to increase capacity for a signalized intersection is to share the green time that's available between fewer movements. Essentially, instead of cutting a pie into 8 pieces, we want to try to cut the pie into 4 pieces, 4 larger pieces, and allow for the dominant movements to get more of the green time. In order to do this, however, we need to reduce the signal phasing, and this is actually the crux of innovative intersections. It's reducing the signal phasing at our signalized intersections. But it's not just about capacity when you think about innovative intersections. It's also a way to improve safety for the vulnerable users, like pedestrians or those on bicycles, as well as improving safety for vehicles by removing conflicts within the intersection itself. Ways that innovative intersections improve at times improve the intersection for pedestrians is they typically have shorter crossings, or they're crossing multiple road beds individually, and it reduces the number of conflict points, potential directions that can be involved in a crash. Other ways is it simplifies pedestrian decision making, and other treatments. Since we have more green time available for the larger movements, we can do some other treatments with our signals that are proven to benefit the pedestrian safety. One is which you give them a green light and let them start crossing the intersection before you release the vehicles from their stop bar, essentially protecting them, making them more visible within the roadway, and reducing the potential for turning vehicles to strike a pedestrian. So I'm going to talk a little bit about what an innovative intersection is. Really, the basic building block of an innovative intersection is a hyper focus on the left turns. And it's not left turns at the intersection, it's how can we remove the left turns and give them back to the traveling public in a different manner. And so these left turn treatments that we look at are displacement, diversion, or removal of the left turn altogether. And I'll walk through what each one of those are. For displacement, the different types of intersection treatments that fall under the displacement category. One is your continuous flow intersection, or CFI. The other is for an interchange. A diverging diamond interchange is a form of a displacement. The second version or category for left turns is diversion. This would include your median U-turns and your restricted crossing U-turn type intersections. And then the third option is you remove it altogether. You can prohibit left turns and throw up a sign and say left turns go somewhere else. You can utilize jug handles, or you can utilize quadrant roads. And I'll walk through each one of these, and so you're aware of what each one of these look like and how they function. So I'll start with a CFI, or a continuous flow intersection. The distinguishing feature of a CFI is the advanced turning of the left turns, the intersection in advance of the main intersection. And so here you'll see the left turns turn to the outside of the opposing through movement in advance of the main intersection. This allows them to run on the same phase at the main intersection as the through movements. Because we start displacing road beds, one form of added safety is to mitigate the potential of the right turning vehicles to turn down the wrong way, and therefore we typically would bypass the right turns and have them turn on the outside of the now displaced left turn. This type of intersection, it does increase the overall footprint at the main intersection from a pedestrian standpoint. Typically, the pedestrian crossings become two-stage crossings, but overall, in comparison to a traditional widening, the benefit of a two-stage crossing ultimately does mitigate the increase in delay and travel time for pedestrians through these. From a signal standpoint, we've now eliminated the need for this particular one. We no longer have an eastbound or westbound left turn at the main intersection. And for this instance, this would be a three-phase signal rather than a four-phase signal. The type of diversion type intersections, I mentioned a restricted crossing U-turn or an R-cut. And I also mentioned a median U-turn. These are also referred to as Michigan lefts, as there's quite a few of them in the ground in Michigan itself. And the whole purpose of these is to essentially send the left turns through the intersection and have them U-turn downstream at adjacent intersection. A restricted crossing U-turn, however, doesn't just handle the left turns by diverting the left turns. It actually diverts all of the minor approach movement and forces them to turn right. Once those movements turn right, what would have been the through movement and the left turn movement, they are then U-turned at a signalized intersection downstream of the main intersection, at which point they travel back through the intersection and complete the intended movement. The difference between an R-cut and a median U-turn is that the median U-turn still allows the minor approach through movement to occur at the main intersection, and it is only diverting left turns. And for this instance, the left turns would then, similar to the R-cut, they would turn right, they would then U-turn downstream at a signalized intersection, and then head through to complete their intended movement. These have shown significant reduction in crashes when they've converted unsignalized intersections to R-cuts or MUTs. And these have been utilized both in rural areas and in urbanized areas where they are looking at increasing capacity or improving safety. The other type of innovative intersection is the quadrant road, and essentially that takes all the left turns out of the main intersection and looks to provide them utilizing one or more of the quadrants around the main intersection. And so for this particular example, all the left turns would utilize this quadrant road. It would add a signal adjacent to the main intersection to handle that increased movement through there. And this allows for increased capacity as well as it allows for longer green times for the main through movements at the main intersection. And those are where your pedestrians are running with the through traffic. And so at times in areas where you implement a quadrant road, you end up providing more walk time for pedestrians, calming their walk across the intersection and improving for that. So we took those tools and said, all right, everything is in play for our improvement at GARS. What can we do at grade to significantly reduce the cost and improve capacity? And so we applied some symmetrical treatments, meaning if we did one thing on one leg of the intersection, the mirrored opposite leg, we were going to do the same thing. On the left, you see a two-legged CFI. This CFI was addressing the two main critical movements, the heaviest left turn movements that were occurring at the main intersection, which is the eastbound left and the westbound left. We developed the roadway geometrics of this. We developed a microsimulation model of this, and we analyzed it to determine, is this going to improve traffic operations? Are there any deficiencies in the way this will operate in the future? What are the other challenges that we see with this type of intersection? So the CFI, we did recognize some of the detriments. It only was diverting two of the left turns out of the main intersection, and so it wasn't addressing all left turns. There were still right-of-way impacts for the southbound bypass right turn and the displaced eastbound left turn. And the location of this eastbound left turn, you can notice this Noble Street here. This is also a signalized intersection, and so it was very, very confined between two signals. And when we microsimulated this, we recognized that there is a potential for queue spillback, and if that queue, that westbound left, the vehicles waiting to complete that displaced movement, if they begin to spill back, it will end up having a negative detriment to Noble Street. The one benefit we did see with this is CFIs have a known quantifiable crash modification factor. This was a requirement of the project for us to be able to document the anticipated reduction in crashes. And the only way to really do that is with known quantifiable crash modification factors. You take those factors, you apply it to your volume, and you can say, we expect a reduction in 20% or 10% or 15% of your crashes. On the right, you'll see a symmetrical median U-turn. And this median U-turn, it actually was, although there's only two locations for those U-turns, the intention was to utilize that for not only the eastbound and westbound left turns, but to also route the northbound and southbound left turns through those median U-turns. So we were diverting all of the left turns out of the main intersection, which was a benefit. Median U-turns also have a quantifiable crash modification factor. And so we were checking that box that we would be able to estimate the reduction in crashes. Some of the detriments of this alternative, we still had some right-of-way impacts. And this neighborhood down here is actually some historical homes. And so impacting historical homes oftentimes is a project killer. And another significant detriment to the median U-turn is the Fort Wainwright is a key critical stakeholder whose buy-in we really needed to gain their buy-in on any of the improvements that we're going to be making at this intersection. This is their main gate. And they did not like the fact that in order to make a westbound left turn out of their gate, they were going to have to utilize a U-turn downstream to complete that movement. They mentioned something about occasional, moving tanks or the occasional warhead, and so direct paths for those types of things were determined to be quite important to them. And so they themselves were very opposed to this concept. knowing that some of these typical innovative intersections and the typical applications for them weren't quite hitting the mark, we started to really roll up our sleeves and get even more creative. And we looked at combining innovative intersections in a new way, not by looking at symmetrical treatments, but individual elements themselves. And so what you see on the screen here is an alternative that we really didn't have a name for it because nothing really exists like it. And so we were just calling it the hybrid, but essentially it's a jug handle with a median U-turn, a displaced left, and a kind of pseudo at-grade DDI. When we developed the microsimulation model of this, it worked extremely well. It worked at the same level that a full-blown interchange or the DDI was functioning at. And so we thought we had a winner with this one. Although the footprint is quite large, it stayed within all existing DOT right-of-way, and it wasn't going to require any right-of-way. Some of the reasons why this wasn't determined to be the preferred alternative was the fact that we are combining these elements in a way that we didn't feel we would actually be able to quantify a crash modification factor for it. And without that, we would potentially be losing our federal funding. Some of the other detriments, although we're utilizing DOT right-of-way, we're impacting a lot of the existing trees. Those trees don't just improve the aesthetics of the intersection, they also act as a buffer for sound to the adjacent homes. And so we did recognize that as an impact. Ultimately, the DOT said, I don't think we could take that to the public and sell it as the solution. And so they said, what else do you have? And we said, all right, give us one more chance, and I think we can come up with something. And that's where we developed the CFI MUT hybrid. This innovative intersection essentially, although it looks like a bowl of spaghetti from a bird's eye view, it essentially is a CFI MUT combined for two of the legs. The eastbound left, as you see highlighted on my screen, they would go through the main intersection downstream to a signalized dual left turn. This signal is highly coordinated, and so vehicles would not be stopping more than once. And they would complete that U-turn and then make a right turn back at Steith to complete their movement. That eastbound left is paired with a displaced westbound left or CFI treatment, at which point they would be located to the outside of the opposing through movement and running on the same phase as that through movement at the main intersection. Similarly, the northbound is a CFI treatment, displacing them to the outside of the southbound through movement, and that is also paired with an MUT movement for the southbound. Like I said, this from a bird's eye view does look quite complicated, and although we're taking one signal and breaking it into three through really good signal coordination and spacing of the signals, we're able to provide some really good operations for this, as well as recognize the safety benefits of those CFI MUT treatments. And so this one really did check all the boxes. It diverts all the left turns out of the main intersection. We were able to develop a quantifiable crash modification factor, just normalizing the CFI and the MUT treatments. There's no right-of-way impacts, and Fort Wainwright was quite pleased to see that really their movement is prioritized and they're not increasing the direction of the vehicle miles traveled. When it came to checking the client's goals of reducing the total cost of construction, the capital cost was estimated to reduce by $30 million. And so we were able to get it down between 15 and when all said and done, around $17 million. Comparing annual maintenance costs, it was also less than if a full-blown interchange is going to be constructed. although the no build from a maintenance standpoint was going to pencil out the cheapest until it reaches a breaking point. And so overall, beneficial cost savings. The question is, how happy do you think the general public was to see such a unique and innovative alternative concept for the GARS intersection? You can go to menti.com.
I don't believe that link is live. But you can think about it.
You can just do yeah, you can think about it. You as a public, you're traveling through this intersection every single day, taking another look, typical T intersection, and one day DOT and some engineers say, hey, I got an idea. We're going to do this. And this is what we showed them. And ultimately, let's just say the answer is C. The public they were not on board entirely from the get-go. They were angry. They let their opinion be heard. And for the most of them, all of them wanted just to go ahead with the DDI, spend the money, even though that would essentially remove funding for hundreds of other safety projects across the state. And that's where the mission gets even more complicated. I'll turn it back over to Jared.
So we're getting into the part of the presentation. We just wanted to touch on some aspects of the profession of transportation engineering that's, I'm not going to say unique, but I'll say it's special to our discipline. Is transportation engineering really touches on so many things. They very much touch on water resources and management of water. Where's the water going to go through our projects? They very much touch on geotechnical engineering and structures and transportation and civil and construction management. Transportation as a profession, they touch on all these things, very multifaceted, and keeps your engineering gears ideally turning, certainly active throughout your career. Another aspect that I know I didn't touch on through my studies in engineering is the public engagement, the public outreach. These are civil projects. They take place within our communities, and they're funded by taxpayer dollars. So we need to get approval and buy-in from stakeholders. Who are our stakeholders? There are many, but most importantly, arguably, it's the public. Are they going to be okay with this project when we put it in the ground? We knew this was a bit of a scary looking project, and so we went all in on our public outreach. Listed on the screen here underneath the icons are a number of the various directions we explored as far as reaching out to the public, and we have some examples where we met with people one-on-one. We would have kiosks or tables set up in grocery stores. We had a project website we'll explore a little bit, online open houses. Keep in mind that we were entering into this project phase at the onset of COVID, so we had to hit the gas on lots of innovations on engaging the public on the subject of this innovative intersection. We have public open houses. Here's a little pencil sketch video. Go ahead and click the link. It might take a moment to load. That we put together, and that was posted on DOT sites and available to the public through Facebook, etc.
Here in Fairbanks, we've always been problem solvers. So when faced with the challenge of delays, congestion, and crashes at the intersection of Gaffney Road, Airport Way, Richardson Highway, and the Steese Expressway, we went to work on a solution. We originally thought an interchange would be the best option, but that would be too expensive and unlikely to be built in the next few years. So we asked traffic engineers, local experts, and you, Fairbanks, what we should do. Based on all this feedback, the option we chose is a continuous flow intersection with a median U-turn. It may look complicated from above, but it will make sense to drivers on the ground. Detailed videos on the intersection are coming soon. Stay tuned for a safer, more efficient, and affordable intersection in 2022. Thanks to you, the people of Fairbanks.
That website's still live, by the way, if you want to explore the project more. You know, I watched that video and I can't help but think that maybe Will and I could have saved you all about 30 minutes of your lives. We should have just played the video. That sums it up pretty nice. It's simple, it communicates to the public, I think the important matters. Now what is that touching on in the professional realm? I mean, it's communication, it's graphic design, psychology, it gets pretty complex. So we have a really diverse team sitting in our meetings and it's a lot of fun. Here's up on the screen. I'm not sure what happens when you pick an icon here. Does it bring you to the website? Are we on the website? So go ahead, Will, click on one of the eyes. I'm not sure if that's a live image or not. So I'll take a step back. At that website, it's reconstruction.com, and we'll post the link later. You can still access these these live virtual rooms, but any one of those icons will let you drill in a level deeper to literature and effectively interactive wikis where you can learn more and more about the project. Move on to the next slide. So we're starting to feel better about the project. We're gaining the public buy-in. We have DOT convinced, for better or for worse, that this is the right solution. Now we need to get into the modeling. This is kind of my focus professionally, is I like to develop these civil 3D, Autodesk civil 3D models that represent the project in the ground. And these are actually the line works, 3D lines that we hand over to contractors, in which someday they're doing it in other states, and we're starting to do it on projects like this in Alaska. They can actually direct their machinery in the field to lay out the project as it was designed at my desktop in the office. On the right, you can see alignments that may have crossed your radar in the textbooks. That's kind of what drives, it's more or less what the public will drive through the intersection, but it's also the foot by foot definition, how we define the project, whether it's where the curves are going to sit, where the radiuses of those curves initiate, where the cross slopes and the war pick up the asphalt goes. That all hinges on these spines, which are called alignments. Complicated project like this, we had, I'm sure it was 40 various alignments. Some of them are center lines, offsets, curves. It gets pretty complicated pretty quick. Go ahead on to the next slide. So here we're discussing what are we handing over to the contractor. It's an interesting thing. We developed this highly complex, highly robust, highly definitive model in the software. And then the next challenge is, how do we get it onto 2D paper? I mean, it's kind of this conflict of processes, but we're still handing the PDFs over to the contractor. It's the document of record, and it's something legible that all users can read. And anybody maybe take some familiarity should be able to pick up these documents and walk their way through the project and the construction of the project. So this project was really complicated. One thing that we did that's different than many projects is we really sat on all these XYZ points, and the contractor was able to go out there, and the survey team was able to go out there and stake out the whole project. Lots of review from lots of parties across the country. HDR is a larger country, but we had input from all quadrants of the nation, all various gurus, and the best of our best were able to chime in on the massage of this project to be the most that it can be. Move on to the next, please. Something we all know in Alaska quite well, that is snow, maintenance of snow. This is some great imagery from above, where we've all seen this from our windshields, but this is how we tackle the clearing of snow in intersections. It takes 4 or 5 massive vehicles, and we need to consider it, particularly in a priority 1 intersection. How are we going to make this process comfortable? On the left of your screen, you can see how we brought in to our design turnarounds and pullouts for, it's up to like maybe 7 massive vehicles, where they could get into formation so that they could enter and re-enter the intersection and take a few passes, whatever is required to clear the priority 1 intersection. And I think this is the last slide in this little chapter, but something that may not come to your attention as you get through your studies is the phasing of these projects. This isn't a 2-week project in construction or otherwise. It's going to take years to build this project. So Will, who I'm sharing the screen with now, developed the phasing of this project, and it gets really complicated. You're not closing down an intersection like this for the duration of the construction. You need to figure out how are you going to move traffic, how is traffic going to flow through the construction site, through this project as it is developed. So there's all this phasing, you know, what are the most important traffic movements that we need to maintain? How can we build around those movements? And how can we close it down for the winter when construction stops in the very best manner for usage through the winter season? With that, we'll call this a mission accomplished. I hope you're able to take away some of the key takeaways we touched on initially, but mostly I just want to emphasize that transportation engineering is a great profession. It touches all the bases, it keeps you active and engaged up here. It's been really enjoyable. Our contact information is on the next slide. Feel free to reach out to us at any time. I'm personally active in the Institute of Transportation Engineers. We have chapters locally, and there's a student chapter here at UAA, which is in a bit of a stressed situation presently since the COVID days. But I'm sure it'll be up and active again in the upcoming months. And you're more than welcome to attend the professional events at any point in time, and you can reach access those events through your professors, and they can certainly get in touch with me. Oh, look, you really have more.
Yeah, something I don't know what happened. These next 2 slides were somehow skipped. I wanted to touch on, that public outreach component. And so not only was it, hey, we need a message to the public, this is the solution that's going to be the most cost effective, it's going to reduce the crashes, it's going to improve your travel time for your commute. This type of intersection, because it looks so intimidating from a bird's eye view, what we ended up doing was developing this interactive virtual map that allowed them to go to the website, click on, well, I always make my eastbound left turn. What does that look like for me now? And we developed these animations that actually show you what it would be like for you to drive this once it's constructed. And this was to help gain more of that public opinion and acceptance of this solution to improve. And so this is, you're driving eastbound on Airport Way. You now have gotten to the main intersection, the GARS intersection, where you are at a red light. You're released for your green light. You travel through the main intersection, and you're approaching that downstream signalized intersection, which you will be arriving essentially on a green. You travel through the intersection, complete your U-turn, where you also are still arriving on green for that right turn. The coordination of this was quite complex. Typically, when we look at corridors, we're progressing eastbound and westbound simultaneously. This was a lot heavier on a stage-based or movement-by-movement type treatment, but I'll walk through the northbound left turn, which is the CFI treatment. And so you're traveling northbound on the Richardson Highway, at which point you get in your dedicated left turn lanes. You arrive there at a red light and you wait. You are then released for a green light. You travel through the crossover intersection to the outside, at which point you typically are arriving on green as well. And so from a level of service standpoint, although vehicles are having to travel through multiple signalized intersections, the signal timing of it has been coordinated in a way that it really reduces the potential of a vehicle having to stop more than once at a signal. And these were quite helpful to help the public calm the public down, looking from a bird's eye saying, I don't know how I'm supposed to drive through that, showing them these renderings and these driver view animations. It showed them that, I'm still making my left turn from the left side of the road. I'm still making my right turns from the right side of the road. It's not as complicated as it looks once you're actually in your vehicle and you're driving through it. The other thing this did was allow us to really see the overhead signing that we were providing to show the drivers that they'll have clear guidance well in advance of the displaced movements to ensure that there's no abrupt movements or undesirable driver behaviors that are going to be created based on this innovative design. I do have, I'll get back to our contacts. I do have a micro simulation model of this. It's posted to my LinkedIn page. So if you want, you could find me on LinkedIn and you'll see a post from me that shows the 2045 AM and PM peak periods of how this will be operating. And then what you see on the screen is the actual intersection under construction. You can see how it really does look like that pretty rendering picture that we developed based on our alignments.
So I understand there's some folks online. Anybody's welcome to ask a question through the chat box down there. I believe that will make it to me.
When is it slated for completion, or?
We were shooting for the end of next summer, but they've made such massive progress through this construction season. It'll probably be done midsummer.
One of the phasing treatments, especially when you start diverting or changing the traffic pattern of an intersection, one thing that we're hoping is that we start incrementally introducing the new movements to the traveling public. And so as the east crossover is signalized, we can start displacing those movements, the eastbound, westbound lefts, while maintaining the left turns at the main intersection, getting them used to it. And then the other thing that was very important to the project team and DOT was to actually get this thing open well in advance of any weather or inclement weather. And so we want to be able to have people start utilizing the displaced and diverted movements. And with the work that the contractor did in the first season, likely we'll start seeing the crossover intersections utilized in late spring or early summer, and all the movements should be displaced. So they'll get used to the traffic pattern when there's no snow on the ground, and they can see all the pretty paint that we have for lane markings.
Hey, Will, we have a question from the virtual realm. It starts off with a compliment, so I might read that part. It says awesome design and presentation. I'm not sure if you heard that well. It says awesome design and presentation. And then she says, I'm sorry if you covered this and she missed it, but for roundabouts and traffic circle type layouts look at.
So yeah, we didn't cover everything we looked at. We did do, typically what I do is we start with looking at the volumes, and I have a roadway backroom, so I'm looking both from the traffic operations standpoint and the kind of roadway design standpoint. And I immediately started identifying some of the site-specific constraints. And so for this instance, the right-of-way in the northwest quadrant, one of the project goals was we couldn't touch a single inch of Fort Wainwright and the Army's right away. But from a traffic standpoint, just the immense volume, the northbound, southbound, and then the heavy eastbound left turn volume for the design year. A multi-lane roundabout, although we did run it through a traffic analysis, it was determined that it would be operationally, it wouldn't work all that well for the design year, and likely it would also have some right-of-way impacts in the northwest quadrant. Other treatments we looked at when we were studying this from an interchange standpoint prior to us getting to a DDI, we looked at just a displaced left for the interchange. We looked at a dog bone interchange. We looked at several different options. And that's one of I think the most exciting things and most rewarding things for what I do is I'm starting with what do we need? What's the solution? And I'm helping develop those solutions, both from what works from a traffic operations standpoint, and then I know this might sound crazy considering what this intersection looks like, but what's practical from a roadway design standpoint. And so from a roadway engineering standpoint, we're really trying to balance those impacts. A lot of times you cannot avoid impacts altogether, but you do try to balance them and try to cause as minimal impact to the adjacent properties as possible. And so I get to really play in a large sandbox and get to test out a lot of different solutions. Some of them work, some of them don't, and some of them advance to actually construction. So we did look at roundabouts. Those didn't really pass the tier 1 analysis. And so we don't really have any pretty pictures to show what that would have looked like.
Not holding you to it, Will, but to handle this kind of capacity, would you have a 4-lane roundabout?
I mean, I don't even know if there is a single 4-lane roundabout in the United States. There are some 3-lane roundabouts. Roundabouts, although they have gained a significant amount of traction over the last decade, all across the United States, they're still a challenge for the traveling public to accept as a solution from a driver comfort standpoint and a driver education standpoint. And the more lanes you add to those roundabouts, the more complicated it is for the driver to understand how they need to operate as they approach the roundabout, as they get in the roundabout, and as they depart the roundabout. But I will say that roundabouts provide significant improvement, not only just for capacity, but for safety. And for a majority of states, I shouldn't say majority, for a handful of states, you need to prove that a roundabout won't work before you can consider any type of other intersection control improvement.
It is an interesting story of public perception, though. Roundabouts were pretty sneered at, certainly in the U.S. initially, I dare say. But now there's a fair number of the public that wants them. We have entities out there that are requesting roundabouts. They want a roundabout in front of their business, or they want a roundabout in their community. Whether or not it's the best solution is another discussion, but they're really gaining traction in the public perception in a positive way. CFI MUTs like ours hasn't gained that same momentum just yet, but we're working. Wait till they see it in operation, they're going to love it. I don't believe we have any more questions.
Oh, I have one, and it's kind of out there. So is there any design consideration given to self-driving vehicles in your experience? It's probably still, a decade out, at least, but I was kind of curious if that's been looked at.
That's an interesting
So-
question. Yeah, you know, in my experience, our designs adhere to all aspects of roadway accepted and standardized roadway design that applies to every roadway in America. So in that regard, electric vehicles should be able to handle these things just as well as any other roadway. There's nothing innovative that gets us outside of design standards.
He was referring to like.
When it comes to autonomous vehicles right now within our profession, I mean, there is a lot of people that are trying to stay ahead of that, trying to drive that conversation to one from a policy standpoint, you know, from state or local agencies saying what do we need to do to be prepared if this is the future. And then it's one of the big challenges is, well, how do you have the infrastructure to handle that? Not only the data, but your signals, you know, they need to talk to each other. One agency may use one vendor for a signal, and it's like Apple and Microsoft. They're both computers, but they may not talk all that nicely to each other. And so there's definitely some challenges from, as Jared was mentioning, our roads were still utilizing, MUTCD, which is the standard for uniform traffic control. So our pavement markings are, even though this is a one-of-a-kind intersection, we're not inventing new pavement markings. We're not inventing new signs. We are somewhat inventing where do you put those signs, and thinking through the guidance of a driver. But from an autonomous vehicle standpoint, this intersection would actually likely work better than if it's only driven through by humans. And the reason I say that is in my microsimulation model, microsimulation essentially is SimCity. It's just focusing on origin, destination. The car starts here, it knows where it wants to go, it knows the path it can take. And then there's all these variables that we can tweak here and do this, so it resembles the way that the traveling public drives through that area. Because you're going to have, here in Oregon, for instance, we drive differently than they do in Los Angeles. Here we are, we stop at a stop sign and we are telling other people to go through. And down in LA, they are a little bit more aggressive. Our headways, we drive further away from the vehicle ahead of us. LA, they drive closer. The range of speed in LA is going to be greater. The difference of the person that drives the fastest and the person that drives the slowest, it's going to be larger. Here, it's not as large, and for the most part, it's the speed limit or 5, not 15 miles higher. And so we take all those kind of driver behaviors, and that's how we calibrate these models. But in the end, if I were to when you drive through this, if you ever go to Fairbanks and you drive through this and you are stopped, the first vehicle that stopped to go eastbound, you're going to make that U-turn, you're at that stop bar, what I will tell you is there's no need to accelerate as fast as you can to this signal. Because if you accelerate just your normal acceleration, what's anticipated, and then you drive the speed limit to that stop bar, you will not hit a red light. Now, if you accelerate fast, thinking, hey, I'm going to get through this as fast as possible, you're going to stop here. You're going to beat that red light or the green light, and you're going to end up stopping here again. And so autonomous vehicles, they are going to act more like a computer than us humans. And therefore, this will become more reliable if autonomous vehicles were driving through it.
Awesome. Thank you very much.
I'll just echo on that. The other aspect that I think would make this intersection easier for an autonomous vehicle is with a design such as this, you get into your lane to turn left, you just stay in the lane. There's not decisions that you need to make after that. When the light turns green, you're not looking for oncoming conflicts. Good idea to keep in the back of your mind, but generally speaking, there's no conflicts. You're not yielding to oncoming traffic. It's a simpler process in that regard.
Awesome. Okay, and then for the folks online and in the room here, the password for today's survey is priorities. It's all lowercase. Priorities, which is part of the title for today. And do you want to do the outro there?
What? I want to thank you guys. I came in not knowing much about transportation engineering, and then now I think I have to have a new career, and it's going to be transportation engineering. I'm not following your footsteps and go from water resources to transportation because it's awesome. Yeah.
Thank you, guys. Thanks for the opportunity.
Yeah, thank you.
Yeah, thank you for having us.
Great, great job.